Hello, everyone, and welcome to another Lunch and Learn put on by your Northern BC Restoration Community of Practice. Today, we are joined by Ian Ruttenberg, who's going to tell us a bit about a water and snow survey project and how it relates to monitoring and restoration. So, Ian is the Water Resource Project Officer for Blueberry River First Nations here in Denizaname, Treaty 8. He works in Blueberry's Restoration Department. I have the Q&A enabled, so we should have time for some questions at the end. You are being recorded, but we will pause the recording once we start on questions. So without further ado, over to you, Ian.
Okay. So I've been working on various monitoring and restoration projects, but two big projects I worked on last year were the BTWSS 2025, which stands for Blueberry Territory Water and Snow Survey, and the BRFN tap water sampling projects. So I'm going to go over that, and then at the end do a quick overview of other water resource monitoring and restoration projects. Okay, next slide. Okay, so previously we had done similar water monitoring in 2024. And if you look to the right, you can see the list of the sites that we actually looked at. Looked at a total of 28 sites over 3 phases: a winter survey phase, phase 1, a summer survey phase, phase 3, and then we did snow surveying, which is phase 2, but we also kind of split that with phase 1 because phase 2 was actually just a single day in March. So we did 2 rounds of snow surveying. And we also did hydrometric monitoring at many sites, which is separate from that project. So next slide. This time, we decided to expand the project dramatically. We now had 6 phases. We have the same winter water sampling. We're looking at base flow. That's still phase 1. But then we have summer sampling, which was now phase 4, because what we had planned was in April to go to some extra groundwater wells and sample them, because ultimately I want to create a pilot groundwater allocation tool, and I need different data from different wells. So that was phase 3. Phase 2 is still the snow surveying, and then we also added new phases. We have these ongoing restoration projects that we have at different sites, and sometimes they're too close to our summer and winter sites to be practical to sample together. So we're like, okay, we can go to some of these more redundant sites or newer sites at a later date and sample them. And that's what we ultimately did in August. That's phase 5, where we looked at like a few extra sites. And then finally, phase 6 is we had all this extra funding for cabin and eDNA sampling. And I personally am more concerned with physical and chemical data, which is what the ALS sampling was. But because of the leftover funds, we're going to do cabin and eDNA sampling. But because logistically, you can't be doing that together with ALS, because then you have crew that has to deliver samples before a 2 p.m. cutoff time. We're going to go to those sites in September, and then we're going to go back to those sites in October, and that's hence why we have a phase 6A, which is the cabin eDNA, and phase 6B, which is we're going to go back to the sites that we don't already have existing data for, and we're going to collect physical chemical data. And then we also had an additional phase where we had some issues come up where we wanted further investigations. They weren't part of our regular plan, but we're going to add them in anyway. So we had a spill site they wanted us to investigate. We had toluene exceedances that we found during the winter that we wanted to go back and retest. And then in addition to that, we did some snow sampling, and that's what we call extra phase, which is, okay, next slide. Okay, so as you can see here are the list of the sites that we actually did visit. We could see that there's significantly more sites that were visited this time around. If it was a brand new site that had no correlation to 2024, it's in bold. If it's a replacement site like our burrow pits, we have it italicized. As you can see, we added in groundwater sites. We have new we have an ongoing burrow pit enhancement project that we wanted to test 3 of the burrow pits from. So we replaced the sites we did last year, and we now did 3 new sites. one on the Absassin trap line, one on the Davis-Wolf trap line, and one on the Yehi trap line. And then what ultimately happened was we originally had 6 groundwater wells. We couldn't get access to them, so we ended up reducing that to 3 sites. And on the day we went to survey, what ended up happening was one of the wells was under maintenance. That one of the wells was completely covered in rocks and concrete, so we couldn't access it. And then the third well was we actually did access, but because it's so open, it had been infilled with cobbles and we couldn't reach the water table. So phase 3 was a bust, but the rest of the phases were successful. When we went to during phase 5, we had initially decided to do 4 sites. We decided to look at a swimming hole that the BRFN community uses. We also decided to look at our Tubit Creek main restoration berm area, which is very close to the bridge where we sampled, which is why it would have been redundant to do it in phase 1 or 4. We also looked at our older beaten survey site at kilometer 0.8 as opposed to the highway, which is what we did in phase 1 and 4. When we went to, and then we also had from our Grizzly complex, we had a spring that we wanted to investigate. When we went there, however, that spring was dry, hence the little red thing you see there. So the Grizzly complex spring was dry, so we ended up replacing it with our older swimming hole, which is what we call Aiken 3, which is right across the street from our current swimming hole. And then in phase 6, these were sites that basically, when I presented the project in 2024, BRFN Council had expressed interest in us doing water quality data at additional sites. So all the ones in yellow are the ones that we did cabin sampling at. Every single site that we had access to, we did eDNA sampling. If we did cabin sampling and then we did ALS sampling later on, that's green. And then if we just did eDNA sampling and we did no cabin and then we revisited it again for ALS, that's in blue. And then of course, one of the sites we were denied access to, which was Deed Creek, hence why it's in red. Okay, next site. We also had the tap water sampling project. Initially, we had planned 10 sites. We were going to look at pre-treated groundwater at the BRFN pump house, and then post-treatment water at the tower. Logistically, it turned out that sampling from the tower takes too long because it has to be operated over several hours. So we ended up replacing that site with the post-treatment valve at the pump house. And initially in phase 2, we didn't yet know, because it was the first time at the pump house, we didn't know which valve was which. So we ended up accidentally sampling a sink, which was called T02C, which did give us post-treatment water results. But ultimately, when we went back in the summer and the fall, we were able to do it at the right set of sites. And then this project actually didn't exist in the winter. So initially, we had one site that was part of the BTWSS project, and that was the Blueberry Restoration building at the community, which is BRFN T01. But what happened is that when the tap water sampling got approved at the end of the winter, we decided to scrap that from the BTWSS project and add that into the TWS, which is why we only had one site in the winter, because the project didn't really start until the spring. Okay, next. Okay, so one of the things we looked at across all the projects is we had field parameters, laboratory parameters, and several other indices. So for ALS laboratory sampling, we looked at general parameters like conductivity, pH, turbidity. We looked at total and dissolved nutrients like ammonia, nitrate, phosphorus. We looked at total and dissolved metals. We looked at polycyclic aromatic hydrocarbons, or PAHs. We also looked at volatile organic compounds, or VOCs. And we also did 3 different coliform tests. We looked at total, fecal, and E. coli. Obviously, coli is a subset of fecal, which is a subset of total, but we did all three tests. For field parameters, we looked at pH, water temperature, conductivity, dissolved solids, salinity, oxygen, dissolved oxygen, and turbidity. And then we also did flow surveying whenever we could during phases 1A, 4, and 6A. We didn't bother to do it as does the tap water, but we did it during those three phases of the BTWSS project, and we looked at discharge and velocity, and we also noted average depth, wetted width, and stream area. And then for cabin sampling, we had additional parameters we looked at, like 100 pebble count, bank full width, air temperature, percent tree cover, etc. But like I said, that isn't really relevant to our results here. Next slide. Oh, there was a little table there that did show some of the parameters, but not all of them. Anyway, as for this slide, here we see table 2. We have all the sites that we actually did visit. So what's cool about this little table here is it not only it lists every site we visited over both projects over all days. It tells you exactly what day we visited that site, and it even says the order in which that site was visited in that day. So if it was the second site visited that day, it'll have a parentheses 2 on it. There's also indicators that says, was a field blank taken there? Was a duplicate? That's noted with an F. If you see an R, that means a duplicate or replicant was taken there. It tells you what phase. It even has the coordinates for every site, and the name of each site is listed here. Now, 4 of the tap water sites we looked at were in people's personal households, which is why that's been redacted in black. Obviously I'm not going to disclose personal household information to the public, which is why I've redacted it from the table. But those are sites T04, T05, T07, and T09. Okay, next. Here we have a map of all of our sites from both projects. Although the tap water sampling project is kind of just going to be a little blob. It's going to appear as a point because it's all just in the community. But all of our sites are kind of listed here, so we see geospatially where they're located. Next slide. And here are our field parameter results. So our results are basically turbidity was the biggest issue we found. While groundwater values were generally below 10 nephelinometric turbidity units or NTUs, most of the surface water sites were well over that. In fact, only one surface site was ever consistently below 5, and that was the reference site Hallow 5, which is basically a head spring at the very top of Smoky Creek. And of course, our tap water sites were below that. All were below 3, except for one reading of 3.56 at the restoration building in the community in the summertime, which would have been phase 3. But many sites, including Blueberry River and many of its main tributaries, such as Fox Creek, Presbyterian Snyder, had well over 50 and in many cases over 100 NTU. Now, what is cool is that unlike in 2024, no sites were over 150 NTU, but that could have just been the timing of when we sampled. So I would expect that Snyder Creek and Blueberry can be several hundred NTU at certain times of the year. pH was wasn't as big of an issue. Most were over 8, but there were some sites that were approaching 7, and some that even, like at Snyder Creek, that even fell below 7. Generally, Fox Creek, Upset, Buick, the tributaries of Blueberry tended to have lower pH, whereas some of the burrow pits and swimming holes tended to have higher pH. Field parameters were actually the biggest issue for the tap water sampling, because what we had is in the spring and the fall, we had very alkaline values, which you would expect from treatment. But then in the for whatever reason in the summer, a lot of our sites had low pH below 7. So that's something we have to investigate going forward. As for the other parameters, the biggest issues there were a lot of our sites had total dissolved solids over 1,000, which meant conductivity was well over 1,000, and in many cases, salinity was over 0.5, which is the reason why 0.5 parts per mil or parts per thousand is significant is that's the cutoff point between freshwater and brackish water. And that occurred at many of the Blueberry, Aiken, Montney, Pingle, and Umbach creeks. So a lot of the tributaries of the Blueberry had really elevated conductivity values. Now, there were occasional calibration issues, which is hence why we have beige. So if there's data here that's questionable, I have it in beige. And then, of course, our temperature readings were typically always unreliable for tap water sites because unlike surface water sites, we were always in a rush and we had to do the tap water sampling back in the office. We had to do the parameters back in the office. And if you know anything about temperature, if it's not done directly in the stream, it's not really reliable. But the other parameters were relatively reliable, though it should be noted that dissolved oxygen does tend to correlate with temperature. Okay, next slide. These next 5 slides, we have table 4, which shows every single exceedance at every site for every parameter where there was an exceedance. And this is compared to both provincial and federal data. And what's cool about this table is it'll actually specify which exceedance followed, whether it was a federal, a provincial, or both. There was, for total coliforms, there's no official criteria, but there are recommendations that were originally from the EPA that are also recommended in Canada, and that was for 1,000. So that's the only kind of unofficial criterion. Otherwise, these are official provincial or federal criteria. And if you go to the end of the table, so go a couple slides forward. Keep going. Next. Okay, so at the very end, we have, in addition to exceedances, anytime a VOC or a PAH, a volatile organic compound or polycyclic hydrocarbon, had a detection, that also went in this table. So we have the exceedances that are all listed first. And then for those 2 analyte tests, generally, anytime there's a detection, that's an issue. So at the very end of this chart, these aren't exceedances, but these are detections. And we exclude the surrogate data because we only include the data that's based on a concentration, like milligrams or micrograms per liter. So the surrogate data where it's a proportional value doesn't count here because that always is going to have a detection. But here at the very end, we see that some of these sites, they weren't in exceedance, but we still had hydrocarbons and volatiles present. Okay, next slide. Okay, so what are some of the results? Well, we did in addition to a detection, we actually had a legitimate exceedance of PAH for the nepheline at Fox Creek. But the more concerning thing was we had toluene that were at several sites. We had toluene at all the sites that are kind of near the Snyder Creek region. We also had it in the Three Sisters Marsh site that we're restoring. And then what we actually did was, because we have a nearby compressor station at Umbach Creek that's been producing flare stacks and incomplete combustion, black smokers, we suspected this may be a cause of toluene in our rivers. So we actually went back and we looked at fresh fallen snow samples, and we actually found that there was toluene in that as well, which is significant because the fresh fallen snow indicates that toluene's in the atmosphere, which means it's most likely being released through a compressor station. We also had investigated a spill site. This was part of our extra phase. We didn't find anything unusual, although we did find mercury exceedance as well as a chloride exceedance at this spill site, which is called TLK01. Coliforms, we almost universally found an exceedance everywhere. It was commonly for all 3 test types, which means coliforms is a big issue. A lot of this is natural, but there's also a lot of farmland. There are a lot of agricultural processes, and there's also residential, industrial areas that are nearby. So there's definitely human causes here as well. As for our agricultural parameter signatures, um, nitrate wasn't found anywhere. Nitrite was only found in the Two-Bit Creek groundwater well. But what was very common was ammonia. And ammonia was found all over North Aiken in two of our burrow pit sites, Blueberry River, Pingle Creek, Snyder Creek, Umbach. And we also found sulfates, which kind of have a bunch of different causes. We found those at many of the same tributaries. Um, we also found a lot of metals. Chromium, cobalt, selenium, vanadium were found at multiple sites. They were extremely common, actually, at a plurality of sites. We found nickel, beryllium, sodium, and silver at several sites. Sodium was found in exceedance at a couple sites. The most concerning ones that what we found were arsenic, mercury, and lead. Arsenic was found in either total or dissolved, was found in two of our burrow pits. Found in North Aiken on Birch Road, which is Aiken 25. It's kilometer, I believe, 11 and a half. We found it at Fox Creek, Snyder Creek. We found lead. Fortunately, no dissolved lead, but we found total lead at the same Aiken Creek, Birch Road sites. We found it at Blueberry at Tommy Lakes. We found total dissolved mercury at the main Aiken Creek on mile 98, as well as North Aiken and mile 98, and north off the Whiplash. We found it at several beaten sites, and we found it across the Blueberry River, as well as Nick Creek and Snyder Creek. Even our cleaner sites had some of our more endemic exceedances like cadmium, aluminum, iron, manganese, and zinc and copper, which is, and they also, a few of them had some other ones worth mentioning, like even our reference sites had high selenium, and there does appear to be nickel that's naturally in the groundwaters up in Pink Mountain. And this is significant because two of our reference sites had some of these exceedances, which does mean that not our more serious ones like chromium or cobalt, but it does indicate that some of our more endemic things like aluminum and copper and iron and zinc are naturally elevated in water, both groundwater and surface water. Hence the endemic exceedances. And then some of these varied seasonally. So for example, nickel and selenium were seasonally mixed, but generally cadmium, chromium, lead, and mercury exceedances were more common in the summer, while arsenic and cobalt were more common in the winter. And some of these do correlate to each other, like generally where you have an arsenic, a beryllium, or a lead exceedance, you also have a cobalt exceedance. And then, like I said, toluene was found in our snow samples, which means that it is precipitating from it is falling from the atmosphere and settling, precipitating. Okay, next slide. As for our groundwater results, we measured headwater from both the depth of the water table and the well bottom depths. As I mentioned prior, phase 3 was a bust, but that doesn't mean we didn't still get some good groundwater data during our projects. Two wells were surveyed directly. Two-Bit Creek, which is a shallow, unconfined aquifer. And then you have a deeper confined aquifer, which is in the Dunvegan sandstone formation. And that's where both Blueberry River and the Blueberry community are sampling from there. For the shallow one, we basically just used a clean bailer, which we used a new one each time because they're relatively cheap. But for the deeper confined well, we had to use an air compressor or gas-powered pump. We did a 3-volume purge at both wells, and we were very careful to place the pump downwind and away from the well so as to avoid potential contamination. When we measure depth to water table, we have 7.28 in February and to 4.534 meters at the unconfined well. And then we have relatively similar results in the confined well. And some of the exceedances we found was we had high pH in the Blueberry well. We had alkalinity exceedances at both wells. We had nitrate, not in Blueberry, but at the Tubit Creek well. We had sulfate in Blueberry. We had coliforms in Blueberry. We had arsenic at the Tubit Creek well. Cadmium was found in both wells. Lead was found in both wells. Manganese was found in both wells. Some other groundwaters that weren't part of the wells had exceedances like selenium in the spring water at Smoky Creek. We had and then we had certain wells, like some had cadmium, whereas other had manganese. So yeah, next slide. For flow surveying methods, generally, we had three different ways of measuring flow in the field. We Okay, so for low flow in the wintertime, we generally use what's called a chip and flow, where you basically take a bunch of depth measurements. You use that to calculate stream area, and then what you do is you drop little like pieces of wood or leaves into the stream, and you record the time the time it takes them to travel a certain distance using a stopwatch. Generally, that's around a meter. But for the shallowest sites, we use that method. For moderately deep sites, which would generally be in the summertime when flow was restored to normal, we used the Flow Tracker 2. And then for the deepest sites where we didn't want to actually go into the water, we used an M9 Flow Tracker. And some sites that are near sites with existing flow data or actually at the same site, we used Water Survey Canada data. And if it was sometimes a little far from that site, we would use the drainage area ratio method to estimate discharge at that site. And in the winter, generally we would skip a lot of flow surveys because what we would find is we'd find that either due to ponding or ice jamming or dry conditions or trace flow or even accessibility, we couldn't determine flow. And that even happened twice in the summertime. For example, at Fish Creek, we had ponding, which you can see in this bottom left picture. And then at the reference site Hallow 7, we weren't able to reach that site due to muddy conditions. Okay, next slide. So what are our results? Well, almost most sites were dry or had trace flow in the winter, except we were successfully able to survey 5 sites using the chip and flow method, and then 3 we relied on Water Survey Canada data. As should be a surprise to nobody, summer flow was considerably higher than the winter flow. The winter flow was highest of the sites we did get data. Winter discharge was highest at Blueberry at Beaton Airport Road, which is Blueberry 07, 0.05 cubic meters per second. As for field sites where we didn't rely on Water Survey Canada, the highest recorded was at our reference site, Hallow 7, which was 0.5. By the way, but that's actually a typo. Blue 07 should be 0.5. Anyway, Hallow 7 was 0.15, and then the highest velocity was 0.67. In the summer, our highest was at Beaton 04, which was based on Water Survey Canada data, and that was 27.767. As for stuff that we actually went in the field, Hallow 7 was 3.718 cubic meters per second. And the highest velocity was found at Aiken 25, which is that Birch Road kilometer 11 and a half site. Overall, I should be surprised anyone that's familiar with the volumetric flow equation, Q equals VA. Generally, the higher the area, the higher the discharge. Although that's not always the case because sometimes velocity can be diminished in certain sites, which was the case at Tommy Lakes. But in general, they do usually have higher velocities as well. But if you look at relative velocity, which is the smaller streams with higher velocities, it tended to occur in the Aiken tributaries and Snyder Creek. And if you look on this chart here, you can see all of our flow data for the year. Next slide. Starting this year, we also implemented some new quality control protocols. Like I said, we had duplicate sampling and field blank sampling. So during every phase of every project, we collected at least one duplicate sample or one field blank, except we didn't start duplicate sampling for the tap water sites until the last phase. But during the BTWSS project, every phase had at least one field blank. And then if it was a phase where there was more than 10 sites, we would generally do one field blank every 10 sites, or one duplicate every 10, around one duplicate every 10 sites. As a result, we ended up having five field blanks and 4 field duplicates during both phases 1A and 4 of the BTWSS project. And then in addition to that, we also had 2 reference sites. We had, which basically were determined to look for background elevation. So we had our head spring at the top of Smoky Creek, which is Hallow 5, which you can see at the top right photo. The top left photo, which we surveyed in the winter, is Hallow 7. We tried to survey that site again in the summer, but mud conditions prevented us from accessing it. Okay, next slide. So what were our QC results? Well, for duplicates, generally you'll compare a control parameter to its duplicate parameter. What we had initially done is all of our sampling was done by ALS, except that our duplicate sets were done by element. And we did that for a reason, which is we wanted to have 2 different companies testing things that had no knowledge that they were testing duplicates. And therefore, we were able to get a more kind of holistic view to test the reliability. And in 46 cases, our relative percent difference was over 50%, and 17 cases where it was over 100%. That may seem like a lot until you realize that there were about 250 to 300 parameters tested per site, and there were a total of 11 duplicate samples taken. So out of the thousands of parameters measured, that's actually relatively good. 2 other QC protocols we looked at were we considered it an issue if, let's say, a primary control parameter was above detection limit, but the duplicate parameter was below detection limit. That happened 102 times. And then 14 times we had a duplicate parameter that was above the detection limit, but the control parameter was below the detection limit. Again, relatively decent, although the 102 is a little higher. Field blanks, our data was actually quite good. All non-pH parameters were below detection, except for one PAH, acinethine at Nig Creek, and at one of the tap water sites. So we had that happen twice. And then the coliform, the chloroform was found at all but 2 field blank sets to be above detection limit. But otherwise, everything was below detection limit other than pH. And pH generally will be more acidic. pH will oftentimes be more on the acidic side when you're doing a field blank, because deionized water is highly reactive with the atmosphere and it tends to produce carbonic acid. So that's why generally the pH of deionized water will actually be low when you get the results back. You did have some exceedances in the tap water, like you had ammonia, dissolved cobalt at one of the sinks. You had lead in the BRFN restoration building, which we think might be due to piping issues. Manganese was found in one of the households, as well as the untreated well water. You had nickel in the well water. You also had sodium that was in exceedance at one of the households. And you had phosphorus that was in exceedance at 2 of the households. And And like I said, ammonia was found in the ammonia was also an exceedance at the pump house. Some of this may be piping issues. And then we compared this to a surface water site, which was Blueberry Egress Road. And there we had the same exceedances we found during typical Blueberry site in the BTWSS project. So we had a lot of the same things like cadmium, chromium, lead, mercury, vanadium, arsenic. And then all were relatively had low turbidity, although naturally the one surface site we looked at had extremely high turbidity. Okay, next site. Sorry, next slide. Here we have a list of all the tap water sites with the confidential household ones removed from the map. Next slide. And then finally we had the snow surveying. So we had all 7 sites that were visited over the course of 5 days in late February that were done concurrently with the water sampling. That's what we call phase 1B because it was concurrent with phase 1A. And then phase 2, we went back and we did all those same 7 sites, but all over one day. So we were able to contrast mid to late February with like mid to late March. So we kind of have a contrast in seasonality. And we used the Prairie Rose sampler to collect it. And then we would use kind of bucket fills and we'd use this to measure snow water equivalent or SWE and average snow depth or ASD. Okay, next slide. Here we have a list of all the snow surveying sites. There's, like I said, there's a total of 7. Okay, next slide. And then the snow surveying results. All sites increased between late February and mid-March, except Two-Bit Creek for snow depth, average snow depth, and snow water equivalent. Overall, snow water equivalent is increasing geographically from east to west and from south to north. That's actually a typo. It should say from south to north. ASD is too geospatially sporadic to note spatial trends. So there isn't really a trend there. There's high of the multiple of the 2 Blueberry River sites we had. Generally, we had lower values at the community and higher values at mile 98. So that means Blueberry River has relatively high variation. It ranged generally from ASD generally ranged from 41.6 at the Pink Mountain Campground to 61.6 at Blueberry River. Generally, average snow depth was 51 centimeters during phase 1B across the 7 sites, 54.7 in phase 2, 52.8 across both phases. And then average snow water equivalent was 96.9 during phase 1B, 105 during phase 2, and 100.9 during both phases, which is a significant increase from 2024. Which generally means that there's a lot higher snow recharge capacity in 2025 relative to previous years. And when you average, and then we compared this to the Fort St. John Airport, where there's ongoing snow surveying, and those values were all lower than our 7 sites, but they did show similar increases relative to other years and are comparable to long-term historical trends going back to 1974. Okay, and then table 6, you can actually see our results here. And then over here in the top left is an example of a snow survey sheet that we filled out. Okay, next slide. So in conclusion, we had some limitations. Like I said, ideally we would have visited both reference sites twice, but we couldn't access the surface reference site Hallow 7 in the summertime due to mud. The tap water sampling wasn't always consistent because, like I said, it didn't even exist in phase 1, which is why we only did one site. And then we weren't regularly sampling both pump house sites until the summer. Otherwise, phases 2 to 4 were okay, but in general, we want to have all sites all consistently sampled across all 4 seasons. Furthermore, as I said before, phase 3 of the groundwater was a failure. and we'll need to go back and try to re-access some of those wells. Occasionally, we'd have instrument calibration errors, like if I was taking a tap water site and doing it back in the office. Sometimes things needed to be thoroughly rinsed, otherwise a pH value might be a little too similar to the previous one. And then, of course, this was the biggest issue with temperature, where anything measured outside of the field is considered unreliable. There were occasional gaps in laboratory data. This was very rare, but it happened a couple times. So on February 11th, for whatever reason, ALS just was not able to test nutrients at Fox Creek, Umbach, or Snyder. And then dissolved metals all missed data except for calcium, iron, magnesium, manganese, mercury, potassium, and sodium on February 27th and March 13th, which affected a total of 6 sites. Some of the groundwater, and then we suspect that Tubic Creek well needs to be cleaned. The Blueberry well was fine, but we do suspect that maybe some of the contaminants may have been due to just the well being dirty because it's been used at the ranch for many, many years. Going forward, we want to do some extra water sampling this year. We're going to start next month in March. We're going to remove coliforms to save time, except at the new sites. We're going to reduce the sites from 42 to 36. We're going to remove cabin sampling, and then we're going to spend that time to actually analyze the previous year's cabin data. Then we have some future projects we're going to be working on. When we finally do get reliable groundwater data at multiple wells, we'll be able to launch the pilot groundwater allocation tool project. Eventually, one of the things that this project has been guiding is by knowing where all the contamination is, we can kind of develop a strategy for cleaning the Blueberry River. And one of my ideas is that we're going to do a constructed wetland project at each of the major confluences, because as this project revealed, all the tributaries are contributing to poor water quality in the Blueberry River. And then let's see what else. Oh, and then we have an ongoing burrow pit enhancement. Now, as for the conclusion of the results in the project, total and dissolved metals are the biggest water quality concerns, except for the pH VOCs, which were rarely found, but when they do, they're the most serious. We attribute most of this to fossil fuel industries, although some of the nutrient contaminants can be due to agriculture. PAHs and VOCs were less than anticipated, but they're a big issue at Fox Creek and especially around Snyder Creek. Surface waters, because of the combination of the toluene and all the metals, including mercury and lead and arsenic, I would say that the Blueberry River tributaries, especially Snyder Creek, tend to be the most contaminated sites. Snow recharge is increasing based on our snow water equivalent and average snow depth data. As for flow data, most of it was traced in the winter, but it was increasing in the summer. And as should be a surprise to no one, big streams have the highest discharge and velocity. Groundwater recharge was apparent at the unconfined aquifer, but was very insignificant in the confined aquifer and may even represent drawdown in Blueberry River. We suspect that the water quality issues in the Blueberry River confined aquifer and also Tubic Creek is due to nearby cumulative effects. One of the things you got to remember about confined aquifers is even though there's an aquitard or an aquiclude which is preventing, usually it'll be like a thick shale or a thick mud layer that's preventing contaminants from going down over a long period of time. Aquifers are not confined everywhere. So as that aquifer spreads out, there's going to be sections that are less confined. And because the Dunvegan Formation is so expansive, we suspect that there's large sections of that aquifer that are hydrologically connected, and that's where a lot of these contaminants are coming from. Cavity DNA sampling the data wasn't ready as of this report, but we will look at it this year. And overall turbidity remains the main field parameter of concern. Okay, next slide. And then briefly, let me touch on some other restoration and monitoring projects we have going on. Since 2023, we've been doing hydrometric surveying at Aiken Creek and Blueberry River with BCER, and then through Alex Bevington at Ministry of Forests. We've also been looking at Blueberry Tommy Lakes, Jedney Creek, and Beaton at Highway 97, and he recently also added in a full turbidity monitor at the same Aiken Creek site that BCR is looking at. What we want to do is we want to now install that full station at Blueberry River as well. So we are planning a future expansion of hydrometric surveying. So we're going to put a full station in at Blueberry, but we also want to add new ones at Montney Creek, Nig Creek, Snyder at Buick Creek Road, and Umbach Creek at Buick Creek Road, as well as North Aiken, which is what we call Aiken 19. We've been doing ongoing wildlife and burrow pit camera monitoring, which is important because a lot of illegal water is being dumped out of our burrow pits. We have a pilot water allocation tool project, and we have plans to do a future groundwater allocation tool project. Some older current restoration projects we've been working with are, we have burrow pit enhanced. We've selected 7 burrow pits that are highly compacted, have low organics, and we want to restore them. 3 of those were actually ones we sampled in this project. We also were restoring the stream Two-Bit Creek to protect it from erosion, and this included the installation of a log crib berm structure. We have plans to replace a culvert at Smoky Creek. That's on hold because of permitting. Similarly, we have plans to restore riprap section at Montney Creek, which is on hold for the same reasons. We successfully restored the riprap area at Pingle Creek. We cleaned up a marsh site that was being used as a dump site going back to the 40s. This was at Pink Mountain. This is called the Three Sisters Wetland Enhancement, and we're now turning it into a recreation picnic site, as far as also trumpeter swan viewing area. And then we've been using a lot of material from Twin Sisters. We'll sometimes use seeds or like capsules from Twin Sisters, but mostly what we're doing is we're using native species directly from the field itself. We use a lot of woody material, and we follow the BCR environmentally suitable species guidelines. We do have additional restoration projects. We're going to now restore the lower section of Two-Bit Creek to enhance bull trout, which is good because there's warmer waters that are groundwater fed. We have ongoing a project where we've been restoring where we're restoring disturbed campsites in Aiken Creek. We're going to now do scouting to determine where in Blueberry watershed we have similar issues. And then there's some areas along Mile 98 Road that we're going to try to do some wetland enhancement. In fact, possibly even divert ditch water to create a new wetland itself. And as for this project that I was presenting on today, the BTWSS project, this is important because this is telling us exactly where our contaminated areas are, which helps guide our restoration projects moving forward because we know exactly what areas we need to target. Okay, next slide. And then here's some pictures of those. Here's some pictures of those restoration projects. All right, next slide. And yeah, the next 4 pages are just references. So go, and go. All right. And that's it. Any questions?
Thanks, Ian. That was absolutely amazing. I'm just going to stop the recording here.
Yeah.